For part A, we need to find the areas of R and S and add those two areas together to get the total sum. For this part of the problem, we need to find the intersection point right here, which you can do on your calculator. And it gives us a value at x equals 1.0328. To find the area of R, we take the integral from 0 to 1.032, which is this intersection point here. And then we go from top minus bottom, so g of x minus f of x. To find the area of S, we take the integral from 1.032 to 2x equals 2, which is, this is given. So from 1, and this time it's top minus bottom, and f of x is on top this time, so f of x minus g of x. I use my calculator to find this answer, and to find the total sum, I added these together to get 2.004.
For B, we need to find the volume of region S, which is right here, whose cross-sections perpendicular to the x-axis are squares. So if you were to draw it, it would be like that, go all the way across. In order to find the volume, we first need to find the area of the cross-section because we use that in the integral. So in this case, the area, it's a square, so the area is side squared because it has 4 sides that are all equal. So in this case, it'll be top minus bottom in order to find the sides, which will be f of x minus g of x. So in this case, we take the integral from 1.0328, because that's this point right here, which is the intersection point, to 2, which is this point, because that's where region S is. And we do f of x minus g of x, because that's the side, and we square that, because the area of the cross-section is at side squared. And after using my calculator, we find that it's 1.283 is the volume.
So for part C, it tells us that h is the vertical distance between the graphs of f and g in region S. So this distance right here. So we know that h will equal the graph f of x minus g of x. And then it asks us to find the rate at which h changes with respect to x, so essentially dh dx, when x equals 1.8. To find dh dx, we can take the derivative of this equation here. So implicit differentiation gives us dh dx equals f prime of x minus g prime of x, and once we have that, we can just plug in 1.8 for x, and we end up with negative 3.812.